I would like to welcome all of you to the ACM Meetup organized by the UCSC ACM Student Chapter, where we will be conducting a special Kubernetes workshop done by DevOps engineer at Eternum, Mr. Kemila De Silva. ACM is the world's largest educational and scientific computing society. At the ACM Student Chapter of UCSC, our goals are twofold. Firstly, to promote interest in computing and its applications, and secondly, to unite people with similar interests. As a volunteer organization, we incentivize our members on the project by offering the opportunity to provide certificates and unique swags at our events. Our projects include the National Olympiad in Informatics, the International Olympiad in Informatics, the International School for Informatics for Juniors, the Asia Pacific Informatics Olympiad, Hash Code, Sport Coders, 8 Weeks of Code, and ACM Meetups. I would like to invite those who are interested in joining to take up the challenge and join with the UCSC ACM Student Chapter in the upcoming recruitment. So we come to the most important part of today's meetup. Mr. Kemila De Silva is a talented professional who received his tertiary education at one of Britain's most prestigious universities, University of Coventry, and now works as a DevOps engineer at Eternum. I would like to cordially invite Mr. Kemila De Silva to conduct the workshop.
All right, thank you very much, Sahan, for the great introduction. And thank you, Chamod, Suin, and the ACM team for this great opportunity to talk about Kubernetes. So yeah, so today's topic is the road to Kubernetes. So before we start the session, let me share my screen first. Can you see my screen? Hello?
Yes, we can see your screen.
Yeah. So, okay. So good evening, and I think I should say good morning and good afternoon where you are joining. So this Zoom live. So before we get started, let me give a quick introduction to myself. I'm Kemila De Silva. I'm currently working at Eternum. So you can, and you will get latest YouTube sessions and Kubernetes Sri Lanka updates on that. So today's agenda would be like this. First, I'm gonna start in the very beginning level, like the traditional way, which means on-prem deployments, how goes on, and then I'm gonna move into the virtualization. After that, talk about the containerization, and finally, let's talk about the orchestration and a comparison between all these models together. So after that, we can jump into the demo. Wait a second, let me turn on my laser point. We can jump into the demo regarding containerization to orchestration. I think I have shared a Medium article regarding this how to spin up a K cluster on DigitalOcean. If you are already created, you folks can work together. All right. So the traditional way deployments, as all of you know, on-premises application deployments. So as you can see here, this is a sample view of on-premises server, and in here, I'm not going to add any firewall or VPN servers and all. So this is a pretty similar one. So according to this model, we have a bit larger physical server, and inside that we need to install the operating system, and inside that we have our application. So first, think about the memory mismanagement. We have applied 8 GB of memory, and application only takes 1.5 GB. So this could be a PHP application on those days. So, and one CPU, and also for the operating system, it takes 5 GB. So this could be vary, but there's a huge memory management as well. And the cost. So all these are physical items, right? So if something goes down, there's a huge cost to replace those items. Then the maintenance. So maintenance side, besides, so we have maintenance cost as well, and there's application. So and this application need to uptime in 24/7. Therefore, the developers could have a huge responsibility as well, and this could be a huge headache for them. Finally, the deployment. So the deployment not easy, right? So as the software computers, so the deployment takes long time period as well. So to reduce and overcome these issues, developers move into the virtualization model. I think this virtualization model now on cloud providers as well. So, but in here, I'm just talk about the Oracle VirtualBox deployment cycle so when we move on to the virtualization model, as you can see here, my sample model, we have a physical server, likewise the previous one, and on top of that, we have operating system, and on top of that, we have the hypervisor. So I'll explain what hypervisor does, and in the top layer, we have the application set. So in here, we could have managed our memory usage, a set of levels, since this hypervisor fully manage our memory, and it can manage our memory and allocated our resources to the applications as well. So this, by the way, actually, there's still they're using operating system, and for the main server and for each applications, they're already still using operating system as well. So if you are already deployed some application on Oracle VirtualBox, so you guys have some experience as well. So, and the same as the previous model, there's a huge cost for maintaining this huge physical server. So, and the maintainer side, as I previously, developers could have huge responsibility to manage those virtual actions. So after that, they put a big step by moving to the containerization. So this is a sample model of containerization, pretty similar to the previous one, but there's a huge improvement. So as you can see here, in our infrastructure, we only have the OS and on top of, and the Docker, and which mean actually, so which I use Docker component in here to understand this containerization model easily. But in the real model, there's no Docker, so it's the container engine, and it acts as a hypervisor, which means it's allocating our resources to all of these applications. So in here, each application no need to install separate OS. So I don't in here I don't add any OS category. But when we build a Docker container, we need to add a base image. I'll explain that part in the demo section. And not only that, actually, if we can build a production level Docker container, use it anywhere as same as the production one. So that's a huge advantage of the containerization model. But if this containerization model more reliable, there's some concerns as well. Just assume this is my common example, which I choose every time. Just take Facebook. So Facebook has tons of containers to run. So just think about how just think about how we are gonna manage them. So they need to run daily tons of containers. So there's a manageable solution for that in the containerization model. So to overcome those concerns and issues, community moving to the orchestration, which means nowadays everybody talk about the Kubernetes side. So apart from the containerization, alternatives for Docker. So we have Podman and Rancher. For the Rancher, there's a huge hype nowadays. And Linux containers, Containerd, and Ramsey by IBM, and Vagrant by HashiCorp. So I have added all the official links in here. I'll share this slide deck to UCSC, then you guys can go through it. All right, the final stage, the orchestration part. So when we move on to the orchestration, as you can see here, we can deploy multiple applications, right? So applications mean in this Kubernetes architecture, applications means pods. So and all these applications managed by Kubernetes cluster, and all these applications inside this single node. And apart from that, so inside that single pod, we could have multiple containers as well. So and to communicate internally in Kubernetes side, they are using services. And nowadays, fully managed Kubernetes services available on any cloud provider like AWS side, EKS, and Azure, AKS, and GCP side, GKE, and Linode, DigitalOcean likewise. So Kubernetes is originally designed by Google. It was an internal project by Google actually, and they replaced it to open source community in 2014. And currently, Kubernetes project fully managed by Cloud Native Computing Foundation, which means CNCF. So in this orchestration architecture, this portability and the multi-cloud compatibility, and there's no headache for the developer like in the previous modules. So there's no headache. So cluster will manage everything. So if we did a deployment, so I mean that part, if we did a deployment, And if something happens, goes on, and if pod goes down, pod automatically spin up and running based on our memory. I think, and this the main advantage is this fully open source, so anyone can use it. Apart from that, I think since this is a Kubernetes related session, I have added some orchestration tools as well. So here we have Kubernetes and Docker Swarm, Rancher. So before coming Rancher, there's a huge hype for Docker Swarm as well. But the popularity of the Rancher is, that's a bit hype at the moment. This could be vary as well. And Marathon by Apache, and finally OpenShift by Red Hat. So let's do some comparison between all four modules. So actually, so we I think those days we are in the traditional way on-premises deployment, but currently some of them are deployed on-premises. But then they move on to the virtualization model. Then we have the hypervisor. So the hypervisor manage everything, manage every memory management in each application. And then they move on to the containerization model, since application need a separate OS to run. So in the containerization model, only the host OS, Docker will manage the application memory and everything. So the containerization containers usage concern, because of that they need to move on to the orchestration part. So in here orchestration, we could have multiple containers inside that pod. Actually, so this model could be changed in the future. So at the moment, what a revolution, right? So in future this could be changed. So future will change everything. So I think that's my main presentation part. So we can jump into the demo. I think if anyone spin up a DigitalOcean Kubernetes cluster, you guys can join with me, right? So I'll show my Kubernetes cluster as well in the DigitalOcean side. So if you are using DigitalOcean, you can simply just move on to the Kubernetes category. So inside that, I have my Kubernetes cluster. So if you sign up for the DigitalOcean, you will get $100 of free credits. So I think you can manage your free credit in this billing category simply. Everything is there. All right. So let's jump into the Kubernetes. You can spin up a Kubernetes cluster simply like this, right? So go to create and Kubernetes, then just select Singapore uh, and the version, put the recommended one, and you can change your node pool as well. So just put 2 nodes at the moment, and you can change your Kubernetes cluster name as well, whatever you want, like it's so it's demo, right? So I think I'm not gonna create one, so because I already have one at the moment. So if you think I need to Sahan, is there a way to change this zoom drop down so I can't move on to the all right. So inside my Kubernetes cluster, I have a node and two nodes actually. So you can directly download this config file, or you can, if you config what's the DigitalOcean command line, you can simply connect your Kubernetes cluster using that as well. So once you connect your Kubernetes cluster, you can see your Kubernetes cluster in here. So in the Docker desktop. So before everything, you need to run Docker desktop, and you need to enable Kubernetes on there. You can simply switch your Kubernetes clusters in here. All right. So I think this is my sample node application. So in the root level, in the root part, my response would be users shown, and I have some other routes as well for the delete, update, insert, likewise. Let's, and also I can share my, wait a second, the GitHub repo which I created for this session. Let me share that one. So then you can simply start work together. Let me share this in the comment section. All right. So yeah, you can clone this repo and do the containerization and orchestration part with me. So let's simply start this node application in locally. So application runs on 3000 port. Let's see. All right, application is up and running. So let's check other routes as well. Delete. Also the one that insert. Yeah, everything works fine. So now I'm gonna close this session and move into the containerization part. So when you move into the containerization part, you need to create a Docker file like this one. So in here, this from work dir, copy, run, cmd, those are the instructions for the Docker file. And from instruction, we need to add the base image. So the recommend part is please always use Alpine images. Otherwise, your container gonna be bit large. So inside that, we are gonna create in a working directory like app, and I need to copy package.json file because I think all of you know in the node side the heart is the package.json file. So you need to copy that package.json file to app directory, and you need to simply run npm install to install packages, and you need to copy everything to this app directory, and you can then run by using cmd command, cmd instruction, not in index.js like I run here. Then you're gonna expose this container to 3001 port. So let's start to build this Docker image. So you can start. You can build this Docker image by using this command: docker build -t, the name of the container, and this dot is highly you need to put that dot actually. So otherwise your Docker command will not work because by using this dot it will gives you this Docker file is inside this directory. So let's run this command. So docker build -t. So that's my application name. No, it's you can put anything else. So I just copy this one and paste it here. So my Docker container is created, and then you can check your Docker container is up and running by using this command. So docker run -p. This is the container port and the host port. So for both I use the same one, and the container name which you are put in here. and the tag at the moment just put the latest one. So Docker -v 2001. So colon latest. All right. Docker container is up and running. So once you start your Docker container, you can check by using this command docker ps. Yeah. So the status is up 1677. Sorry, 1877. So let's check it once again. All right, please up and running. And let's check all the other routes as well. Okay. Update. All right. Everything works. So I'm just gonna stop this. So you can stop your Docker container by using this command docker stop. You need to copy this container ID and paste it here. All right. Docker container it's down and low, so you can't, right? You can't access it. Then we can sorry. Then we can tag our Docker image and push it to any other container registry. So at the moment I'm using Docker Hub. So I think first we need to create a Docker register, Docker container register as well. So, this is a URL for that, hub.docker.com. So I already signed in, so you can sign up and join to the Docker container registry. Then create a public repository. So it's demo UCSC. All good. Let's create it. All right. So this is my container registry. Then I'm gonna tag my container and tag my Docker image and push it to this Docker registry. So to tag your Docker image, you can use Docker container, Docker image. You can use this command docker tag your container name and your username and the repository name which you are used at the moment. So this one means You can simply copy that part. Let me tag my container, docker tag server. This is demo UCSC. Docker tag container name server. And when you're tagging your container, please don't put like this way. So just put a correct version like 1.0, 1.1, or any other version would you like to put, because that's the best practices when you are tagging our Docker containers. Please use it. So once you tag your container, you can simply push your Docker container to Docker Hub. Let me do that one as well. Docker push and our tag Docker push our tag container with the version. So it will take a bit time. So while it's pushing, anyone having issues at the moment? Or... All right. So I think our Docker image pushed to the Docker registry successfully. Let's see. Yeah, version 1 is there. So you can pull this version. So like I said in my presentation, you can simply create a production level Docker container and push it to Docker Hub or whatever, the ECR or the container registry, and simply you can just pull this Docker container and run your machine, same as the reduction one. So that's the main advantage of this containerization model. So yeah, I think once we done that part, we can simply then move on to the Kubernetes side. So in here, I try to create a deployment, Kubernetes deployment. So for actually this inside in the Kubernetes side, everything runs everything done in YAML format. So you need to create a deployment.yaml like this name. So case demo deploy.yaml, just a YAML file. And this in here, I'm gonna create a deployment. This kind means the type which I want to do deployment, and the API version need to add. So this is my deployment name, Node.js deployment, and I'm gonna create a pod inside this deployment. So it means when you create a deployment, it will automatically create a set of pods. So this is my pod name, Node.dev, and this replica spin, how much of pods you need to run. So at the moment I put two replicas. So you can put one or three or anyone. So three or you can put anything. Then you need to name to the deployment, not depth, and this is the pod template. So pod name is not depth, and this is the container you are using. This so this is the container image. You need to put which we push it to Docker registry. Let me copy that one again. So if you are putting any private private repository image, you need to add a secret. So in Kubernetes side, there are secrets, services, deployments, pods, stateful sets, likewise, so many things here. So you can create a secret and add your credentials in here, and you can simply add your secret in here by using that credentials. And you need to put your container port. So 3001 we are running at the moment. So save our deployment. We can create a deployment using this command, kubectl create -f. So sorry, before we jump onto the deployment side, you need to check your Kubernetes cluster. So please make sure to check your Kubernetes cluster, otherwise you deploy another. You're going to deploy another cluster. So this is my Kubernetes cluster, which I configured on DigitalOcean side. All right, let's create this deployment. Create -f and the file name. Case demo deploy.yaml. All right, deployment is created. Think we can check it on kubectl get deploy. All right. This tree means I have added 3 replicas, so it means to run 3 pods inside this deployment. Kubectl get pods. All three pods are up and running. All right. So let's add the load balancer. Let's add the load balancer to this deployment and see how our application runs on through the internet. So by using this command, actually, you can simply expose your deployment to a load balancer. kubectl expose the whatever the thing you want to expose. This is the deployment and the deployment name and what type. So type is load balancer. So I'm simply copy this command. Deployment name is not just deploy. Okay. All right, service created for my deployment. Let's see. CTL get SVC. Still pending my external IP. So this is the internal IP. So let's wait till come in my external IP. This is the load. It means the load. So while it's coming, anyone having issues at the moment? Anyone doing together with me? Hello? You folks can hear me right now?
Yes, we can hear you.
Yeah. Anyone having issues?
Hello, Kemila. A small question. So, in the port mapping, 3001 here is is it the internal port? Or I mean,
3001 is the container port.
The port which is exposed, right?
Yeah. The container port and the 32270 is the Kubernetes side internal port.
But like our application is running on 3000.
3001.
On Docker, if we do that, we should put the internal port as 3001. So in Kubernetes, how does that work?
Yeah. So as I said in here.
Yeah.
So we need to add the container port in the deployment.
Okay.
So it will pick the port. So otherwise, application goes down. So they need to find the port. So you need to put the correct port in here. This is the template of the port side.
Okay.
So you need to add the container URL in the image category and the port in here and the name of the port.
Yeah. Okay.
Yeah. Port mean application. Yeah.
Okay. Thank you.
Okay. Let's see. Externalities. No. Okay. We have externality. So let's check it on our browser. 3000. sorry, not 3000, 3001. Sorry, I was wrong. So I think anyone can access this application at the moment by using this IP. I'll share that one. So did I share? And you can check your other routes as well. Delete and insert. Yeah, one. Update. All right. Everything works fine. So this is a pretty sample application deployment. You can do large scale one with the same way, which I did. Yeah, I think that's it for the demo side. Anyone having any issues at the moment, so I can answer. Actually, please use Alpine images when you create Docker files. So I'll share this URL as well. So you can see the difference. I think they have added some. So yeah. So if you put a Ubuntu main noise and if you put a Alpine image, so this is the difference between all of them. So it takes only 36.8 MB, but if you choose Ubuntu base image, it will take 145 MB for the base image set, and then your container gonna be bit large, and the purpose of containerization would be not effective actually. That's the correct answer, I would say. Anyone having any issues?
Hi, Kemila, it's Suvin here. I have a small question. So, when there are a lot of pods, how do you make sure that all the pods are always running? Something similar to a health check.
Yeah, so you can so in the open source side, you can add Prometheus or any monitoring mechanism. So to connect your Kubernetes cluster directly, and then Prometheus also runs as a pod inside your cluster, and you can in the monitoring side, I would say Prometheus, Alert Manager, and Grafana. The main monitoring stack, you can simply add your cluster, and I'll share that one as well if I can. Let me see Prometheus. There's a main Prometheus stack. It includes Prometheus, Grafana, Node Exporter, likewise the main monitoring stack, Cube State Metrics. Just have GitHub. On this one actually. So I'll share that one so later. So I couldn't find the correct one at the moment. So once you configure it, so you can simply uh, set up your alerts to Teams or emails or any other uh, alerting platform. Alerting means any chatting or any other email service. And if pods, so if not memory or insufficient, so it will trigger alert. Then you can find find your application needs up for application healthy at that time.
Yeah, cool. Sure.
I'll share that link soon. Sorry, so I couldn't find that.
It's okay. Thanks.
Anyone have any issues? Anyone having any issues at the moment, or anyone have any questions, concerns regarding this? And also, there's a quick another knowledge level thing. So in Docker side now, Docker is not fully open source. So Docker has some pricing category at the moment. So if you are running, if you are set up a Jenkins or GitHub Actions or any other CI/CD tool, please make sure to don't use the Docker Hub, because if you are in the Jenkins side, I would say if you tick the poll ACM1, so it will automatically trigger anyone directly commit to the GitHub. So then there's a limitation for the image pool, image pools. So for anonymous user, I think that's 100, and 100 times of image pools, and for the personal life, there are some limitations at the moment. Before that, there's no any limitation. So make sure to, when you are doing in a company, personal or any other workspace, so please make sure that as well. Anyone having any issues at the moment? So I can quickly jump into another exciting, actually, the event which we organized. So before that, anyone having any issues? No, I guess. Swin, do you have any issues?
I'm all good. My own side.
So this is a quick heads up. So for the first ever Kubernetes community, this will take place on August 6th to 7th. So in August 6th, we have organized the main event, and the 7th, we have organized some demos related to Kubernetes side. So lots of overseas speakers will join. So you folks can follow our social network and get updates immediately. So it's a quick heads up. And I think thank you very much, UCSC, for this great opportunity, and thank you, Suvin, for giving this opportunity. Thank you for having me, and I hope you got some idea about the Kubernetes side. Thank you.
So now I will open the floor for questions. Does anyone have a question? All right, proceeding. Thank you, Mr. Kemila, for answering and conducting an insightful workshop. Our heartfelt gratitude goes out to you, sir, for taking time from your busy work schedule and conducting a workshop for the students of the University of Colombo School of Computing.
Thank you very much, Sam. Thank you very much. I highly appreciate it. Thank you.
I would also like to make a small request from everyone. There is a feedback form regarding your personal experience during this workshop. It is provided in the Zoom chat, or you could also scan the QR code shared on the screen. Filling that would greatly help our team correct our mistakes and also help us make the next event an even better one. So please fill it. Every good thing must come to an end, but every end is a new beginning. It's time for us to mark the end of this workshop. My heartfelt appreciation goes out to our executive committee of the UCSC ACM Student Chapter and also everyone who stayed with us from the very beginning and supported us in numerous ways to make this workshop a success. I'd like to thank everyone who joined today, and I hope this remains a lifelong memory in your mind. Until we meet again, stay safe and goodbye. Signing off, I am Sahan De Fonseca, and this was the Kubernetes workshop organized by the UCSC ACM Student Chapter.